Picking up where we left off, what would you have to add to 2 pi over 5 in order to equal a whole pi? You would have to add 3 pi, 3 pi over 5. All right, and if we look at the last one, in order to be a whole pi, the easiest thing to figure out is the supplement here. If we start with that, in order to be a whole pi, we would have to add another 1 pi over 5, or just pi over 5. In order to find, so that's the supplement, because that takes us all the way to 180 degrees. If we want to find the complement is 90. And we had 4 pi over 5. So that was going all the way over to there. And in order to get just to pi over 5, we would subtract. As we look at our drawing, though, we recall that this angle is already greater than 90 degrees, so therefore the complement would have to be a negative angle, so we're not actually going to have a complement in this case. All right, the next thing to think about is how radians and degrees are related. So if you have a circle that contains 360 degrees, and that is equal to 2 pi radians, then we know that 1 degree is equal to pi over 180 degrees. And if we use the same thing and we solve for radians instead, we know that 1 radian is going to equal 180 degrees over pi. So that information, that ratio, 180 degrees over pi or pi over 180 degrees, that is how you're going to convert between degrees and radians. So if you're going to convert degrees to radians, then you're going to multiply by pi over 180 degrees. You can think about it like units. If you had x degrees here and you wanted it to equal radians, what you have to do is you have to multiply by something so the degrees will cancel out. So we need the degrees on the bottom, and that way our units cancel out, and we're just left with the pi radians on the top. If we want to convert to from radians to degrees, we are going to multiply by the proportion flipped. So 180 over pi. It would also be wise of you to take a look at this diagram. You're going to get used to drawing this, but in terms of thinking about fractions, the easiest way to do it is to think in terms of 30-degree units and in 45-degree units. So our 30-degree units are pi over 6, pi over 3, 2 pi over 3, 5 pi over 6. Oops, sorry, I skipped 90 and 180. And then 4 pi over 3, and here, and here, and here. And then we come around here. So if you think about fractions, this is pi over 6. This is the same as 2 pi over 6. This is 3 pi over 6. This is 4 pi over 6. It's just a simplified fraction. Here you get to 5 pi over 6. This would be 6 pi over 6, but it's a simplified fraction. 7 pi over 6. This is 8 pi over 6, simplified fraction. 9 pi over 6, simplified fraction. This is 10 pi over 6, simplified fraction, etc. And then we get to 11 pi over 6. So you can see how if you know your 6's, you can count all the way around. The same is true for the 45. So we can start at 0. This is pi over 4. This is another multiple of 45, multiple of 45, multiple of 45, multiple of 45 here also. And you can see as those go around, this is pi over 4. This is also 2 pi over 4, which is the same as pi over 2. This is 3 pi over 4. This is 4 pi over 4. Hopefully you're recognizing a pattern as you go along. It would be worth taking a look at that and paying attention to it. Okay, so let's convert the following from degrees to radians. So we have 135 degrees. If we want to convert it to radians, 135 degrees, we're going to multiply by that pi over 180 or 180 over pi in order to cancel out the degrees. So pi is going to go on top, 180 is going to go on the bottom. Put that in your calculator, leave it in terms of pi, and you get 3 pi over 4. Let's go to the cast for a second just so you can see it. So I would type in 135 times, the pi button is here, and then I can choose it. Oops. And then I'm going to hit divided by 180. And when I hit enter, because I have a cast, it gives me my simplified answer in pi, in terms of pi. If we do 540, same thing. 540 times pi over 180. We put it in our cast, we end up getting 3 pi. Negative 270 degrees, multiply by the same thing, pi over 180. And you end up getting negative 3 pi over 2. So those are converting from degrees to radians. If we want to convert from radians to degrees, we're just going to flip that conversion factor. So here we would have negative pi over 2 radians. So we multiply it by 180 over pi. That way our pi's cancel out, and we just get negative 90 degrees. Here we have 5 pi over 3 radians. Again, we're going to multiply by 180 over pi. The pi's cancel out, and we end up getting 300 degrees. Here, be careful. This is not 3 pi radians. It's just 3 radians. So this is like radians in decimal terms, not in pi terms. So here we're going to get a kooky number. So we're going to have 3. If your calculator is not in radians, you need to make sure that you put it in radians so it understands what's going on there. So let's go to our CAS. In order to put something in radians, you can hit menu, and then that is not right. Document settings. So you hit document, hit number 7. You want document settings, and you can just come down here and choose radians and set OK. So now you can see that it's in radians because it says up there rad. And if I put 3, and then I'm going to multiply by 180 divided by pi. When I hit Control Enter, it gives me that decimal, 171.887. So this is 171.887 degrees.